Okay, this is part two of the ramp question. So we've solved this by adding the vectors tip to tail and found out that our coefficient of friction is equal to the tan of 30 degrees. So I just wanted to bring in a calculator here and get the tan of 30 degrees, and that works out to 0.577. So the actual coefficient of friction to 3 decimal places would be equal to 0.577. Okay, just to complete that off with a number to give you a feel for what that would be. Okay, so now I'm going to go at the same problem, an equilibrium problem where all the forces are balanced, but this time we're going to use a coordinate system. Okay, so instead of doing tip to tail, we're going to look at left and right and up and down. But what we're going to do here is, because everything's tilted at this angle, we're going to make our x and y coordinates go like this. So this is going to be the x direction, okay? And this is going to be the y direction. So you just have to turn your head a little bit. Okay, this is the coordinate system that we're going to work with. And the reason, one of the main reasons for choosing this is that, hey, this one is already just strictly a y force, and this is strictly an x force. So now all I have to do is take my force of gravity and break it down into its y component, which would be downwards along the y-axis, and an x component like that. Okay, so if this is Fg, this could be called Fgx, and this would be called Fgy. And you see how these two forces added tip to tail add up to this force right here. So these are the components that make up this force. Okay, so just to label that right here, this is the force of gravity. Okay, so in order to find Fgy and Fdx, I need to know some angles in here. So once again, I would go just extending this line down kind of in my mind to notice that this is 90. From our original question, this was a 30-degree angle, which means that this is 60, which means that that opposite this x is 60, and this up here would then be 30, because this is also a 90 here. Okay, so we know that this angle right here is 30 degrees. Okay, great. So it looks like from the 30-degree angles point of view, this is the opposite side, and this is the adjacent side. So we know the hypotenuse, and we're trying to break it down into the opposite and the adjacent side. So we can write that cos of 30 degrees is adjacent over hypotenuse. Okay, and the adjacent is Fgy. Fgy over the hypotenuse is Fg. So rearranging this, we have that Fgy equals, we multiply both sides by Fg, we get Fg times cos 30. Okay, it's a little bit different from, you know, our sort of standard coordinate system that we work with. Usually the y coordinate ended up being related to the sine of the angle, but it just depends what angle you're working with and what angle your coordinates are at and all that sort of thing. So when in doubt, refer back to the SOHCAHTOA. Okay, label your sides. This here is the opposite. So if we're interested in FGX, we're going to go sine of 30 degrees is equal to opposite over hypotenuse, so that is FGX over FG, and then if we want to solve for FGX, we're going to multiply both sides by FG, and we come out with FGX equals FG times the sine of 30 degrees. Okay, so we found these two components of our gravitational force. Okay, so stay tuned for part 3.